All throughout history, humanity's greatest minds have grappled with the mystery of gravity. From early stargazers who watched heavenly bodies move across the sky to Sir Isaac Newton, who introduced the concept of a gravitational force pulling objects together, to Albert Einstein, who revolutionized our perspective by interpreting gravity as a curvature of space-time. Each step has reshaped our comprehension of the cosmos in extraordinary ways. Yet for all our insights and achievements, unanswered questions have long echoed. Why do galaxies spin at such unexpected speeds? What really happens at the center of a black hole? Are the phenomena we cannot yet explain, like dark matter or dark energy, simply illusions caused by misunderstandings of gravity itself? Today, we stand on the precipice of a new era in understanding. In Gravity and Creation, the unified theory of the cosmos, author Larkey offers a groundbreaking perspective that may transform our view of reality as fundamentally as Newton or Einstein once did. Already available on Amazon Kindle with a paperback edition scheduled for release in January 2025, this book sets forth a bold theory that challenges common thinking about gravity and the very nature of our universe. In this illuminating essay, we journey through the core ideas of Larkey's work, explaining, in everyday language, why this could be the key to one of humanity's most profound mysteries and how it reshapes our cosmic story. Gravity has always carried a sense of wonder and power. Our ancestors named gods and legends after the planets, entranced by their movements across the night sky, never knowing the exact mechanism that held them in their orbits. Newton unveiled the notion of a universal force, mathematically describing how apples fall and planets revolve. Einstein then shattered our classic picture. In his vision, massive objects warped the fabric of space-time, guiding planets like marbles on a curved rubber sheet. This shift was monumental, lending us new precision in predicting the behavior of stars, planets, and light itself. Yet despite these strides, cosmic puzzles remained. Observations have suggested the presence of dark matter and dark energy, hypothetical ingredients we introduced into our equations to explain why galaxies spin too fast at their edges, or why the universe expands at an accelerating rate. We have built entire cosmological models to accommodate these unseen substances or forces, yet the direct evidence for them remains elusive. Could it be that we simply misread the nature of gravity? According to Larkey's new work, Gravity and Creation, the unified theory of the cosmos, the true power of gravity might lie in recognizing that it is not merely an attractive force or a curvature phenomenon, but rather an emergent result of cosmic fields and vacuum pressures working in concert. The book invites us to reinterpret black holes, the rotation of galaxies, and even gravitational waves using a radically different framework, one that claims to eliminate the need for dark matter and dark energy altogether. In Larkey's vision, gravity emerges from layered and subtle fields, woven together in a dynamic universe far more alive than we typically imagine. Instead of viewing space-time as purely geometric, an elastic fabric that deforms under mass, Larkey proposes that we should think of the universe as suffused with a subtle magnetic field, SMF, and the relative vacuum of space, RVS. These elements, Larkey argues, create gradients of pressure that generate the effects we call gravity. Essentially, matter does not pull objects inward. The cosmos pushes them through pressure differentials at every level, stars, planets, and even black holes. This approach changes how we see black holes, those enigmatic corners of space-time where Einstein's equations predict singularities and event horizons. In Larkey's scenario, black holes become pinch points of intensely pressurized vacuum conditions rather than mere wells of space-time curvature. Such a reinterpretation has enormous implications. If black holes are not simply gravitational abysses, but vortexes of cosmic pressure, it reframes everything from how light bends around them to how they merge and emit the gravitational waves we've detected with instruments like LIGO. More stunning is the theory's handling of galaxy rotations. astronomers discovered that stars in a galaxy's outer regions move faster than expected under Newtonian or Einsteinian gravity alone. The conventional fix was to suppose an invisible halo of dark matter providing extra mass. Larkey's framework, however, offers that these rotations can be perfectly explained by higher-than-expected vacuum pressure gradients at galactic scales, negating the need for unseen matter. If proven in observational detail, that would be a triumph akin to removing the scaffolding of dark matter from cosmic models, something that would send ripples through astrophysics akin to the shock of discovering cosmic expansion nearly a century ago. One of the greatest confirmations of modern gravitational theory has come from the detection of gravitational waves by LIGO, the Laser Interferometer Gravitational Wave Observatory. This monumental achievement, first announced in 2016, showed that ripples in space-time really do travel across the cosmos, often emanating from black hole mergers. The equations that predict these precise signals, known collectively as black hole perturbation theory, include the famously challenging Tucholsky master equation, a pinnacle of complexity in astrophysics. Historically, solving the Tucholsky equation for spinning or Kerr black holes has required massive computational resources and advanced numerical methods. Yet these solutions align spectacularly with real waveforms from LIGO, thereby validating the Einsteinian approach for black hole mergers. Now, L.S. Larkey's theory makes the astonishing claim that one can replace the traditional mass-based curvature in the Tucholsky framework with the concept of vacuum swirl and pressure boundaries and still get the same wave signals. In other words, the LIGO ringdowns and quasi-normal modes, once believed to be exclusively explained by Einstein's geometry, could also emerge from a push-based model of gravity if the numerical values match appropriately. This statement is far from trivial. The Tucholsky master equation is notoriously complex, standing at the apex of theoretical astrophysics. By seamlessly reproducing its solutions, Larkey's subtle magnetic field and relative vacuum of space approach essentially passes the toughest exam we can throw at any gravity theory. If you truly can generate the same wave patterns that LIGO measures, then you have effectively solved the most complex puzzle in black hole astrophysics. No small feat. It suggests that where Einstein's framework sees curved space-time, Larkey's sees swirling vacuum pressures, but the cosmic events and signals remain the same. For scientists and enthusiasts alike, this is a breathtaking possibility. The ultimate test of a modern gravitational theory rests in its ability to match the precise signals we record from events billions of light-years away, such as black hole collisions. When LIGO made its historic first detection of gravitational waves, it confirmed Einsteinian predictions with astonishing accuracy. For a new theory to supplant, or even stand equal to, general relativity, it must replicate those waveforms just as perfectly, or better. Remarkably, gravity in creation claims to do exactly that. The mathematics behind the scenes, though not included in detail for a lay audience, purports to show that if one relabels the conventional mass and spin parameters of a black hole as new vacuum pressure and vortex parameters, the same gravitational wave signals emerge. This means that black hole mergers in a push-based vacuum environment can produce ringdowns identical to those of a pull-based, mass-centric black hole. The significance of such a result cannot be overstated. It suggests that the fundamental phenomenon of black hole coalescence and the subsequent wave signals do not inherently require the geometry of space-time explanation. Instead, we might interpret them as elaborate pressure-driven events in a cosmic ocean of vacuum states. L.S. Larkey's gravity and creation. The unified theory of the cosmos stands on the threshold of either being a bold but transitory idea or a towering monument in the history of science, much like the leaps of Newton and Einstein. By eliminating dark matter and dark energy through a new lens on gravity, it addresses head-on the unsolved riddles haunting modern astrophysics. If the predictions hold up, entire subfields of cosmology may pivot, and our cosmic self-portrait may take on vibrant new hues. Crucially, the availability of the book on Amazon Kindle, with the paperback to follow in January 2025, opens the door for global readers, both professional and amateur cosmic enthusiasts, to judge for themselves. Such democratization of knowledge is vital. Revolutionary ideas flourish when a wide audience can weigh them, debate them, and even refine them. From black holes to swirling galaxies, and from subtle fields to cosmic expansions, gravity and creation. The unified theory of the cosmos promises a narrative that might well become legendary in the annals of humankind's quest to comprehend the universe. In this sense, Larkey's new theory is more than science. It is a story of human curiosity, resilience, and wonder, of daring to look beyond established norms and see the cosmos anew. For thousands of years, gravity has enthralled us, first as mythic gods, then as invisible forces, then as curved geometry. Now, it stands poised to enthrall us once more, with the possibility that it is the cosmic push of vacuum pressures, choreographed by subtle fields, that truly underpins the grand symphony of creation. And if that proves true, if it indeed helps solve what many call the most complicated equation in astrophysics, in perfect harmony with LIGO's gravitational wave conformations, then we will once again realize that our cosmic journey is nowhere near complete. There is always another horizon beckoning, another swirl of knowledge to inspire, and another vantage point from which to glimpse reality in all its infinite majesty.